of the rope to an ordinary ice cube. Now we put pinches of salt on top and wait for the reaction, during which the ice melted a little. But not everything is so simple. If you pull the rope, you'll realize that the cube is frozen to the rope, and very hard. No matter how you swing it, it won't fall off. And now, let's take a bigger cube and add salt that will need more than a couple of pinches. We will distribute it and attach an ordinary towel on top. We will firmly press it and turn it over so that the cube presses with its own weight. After about 2 minutes, the cube froze to the towel. And it can even be lifted into the air. Incredible reaction of ice with salt. We will need half a liter of water in a bottle. Let's leave it for about 4 hours and then put it in the freezer for another hour and a half. Carefully take it back out. Now strike one light blow and the water starts to freeze right in front of your eyes. Incredible, isn't it? Or you can hit the bottle on the table and get the same effect. And if you try to pour this water into a glass, it will begin to form an ice column. Carefully pour this water into a glass and then attach an ice cube to the surface. The water begins to gradually crystallize, and after a couple of seconds, the cube quietly stays on the solid surface. Tiny piece of ice is enough to trigger a freezing reaction in the whole glass. And just look how beautiful it is. By the way, you can pull off a similar trick with cola. But you need to freeze it for about 3 hours and 15 minutes. Open the lid by activating the gases, and then abruptly close it. And hit the bottle and the cola instantly turns into ice. Again, the trick with the lid. Then hit the table, and instead of a drink, it's an ice block. Let's take an ordinary ice cube and hit it with the hammer. It instantly shatters into small pieces. And now an unusual cube. The first blow didn't hurt him, and the second, and the third, and fourth. It's like it's indestructible. What's its secret? It's synthetic insulation. Pour the water into the ice mold and put the insulation in there. We fill it to the top and fill it with water all the way till the end. We'll freeze it and take our cube out. It looks like an ordinary ice, but even a hammer can't handle it. It's amazing how much its properties have changed from a piece of insulation. Let's take a fruit juice and pour it into a plastic bag like this. Let's put the bag in a bigger bag and now surround it with ice. Evenly distribute it over the entire area of the packaging. It is important that the juice bag remains exactly in the center. And now add salt to the ice at a decent amount. Close the bag and distribute the salt inside so that it comes in contact with all the ice. Wrap it with the paper towel and leave it for 10 minutes. We take out a bag of juice, and what do we see? It seems we have a whole package of delicious fruit ice cream. In just a couple of minutes, you'll lick your fingers. Here we have 3 vessels with seemingly identical liquids. We gently lower a raw egg into each one of them, gently lowering them along the wall. And now let's add ice cubes here. In the first vessel, we have alcohol, egg, and ice drowned. In the second, there's fresh water. The ice has surface, and the eggs in the bottom. And in the third vessel, we have salt and water. There's ice and egg on the surface. Pour into a glass of water to the very edges and drop an ice cube into the water. The ice has melted, but the water doesn't seem to have been spilled. Then, we'll add another ice cube. Has melted, but the water's not overflowing yet, so immediately the third one. The third cube also did not allow the water to pour out, but unfortunately, the fourth place was not enough. And now we need water, soda, and vinegar. Mix soda and vinegar in the saucepan with a violent reaction. Let's leave them for about 3 hours. When the reaction is over and we got this mass, to which we will add more water. Turn on the gas and put the pan on the fire. Stir them over low heat until the liquid becomes almost transparent. Pour it into a glass vessel and leave it to cool down at room temperature. Pour a little of our liquid on the surface and it immediately begins to crystallize. We'll pick up a little powder from the walls on the pan with the wooden stick and dip it into ordinary water. Like snowflakes, they spread over the entire surface, as if freezing the water. Look at this pattern. The more points there are, the faster the reaction proceeds. Just look how beautiful it looks. Let's try to crumble our crystals. They look like ice, but they are hot. If we smoothly pour out our liquid, then it'll begin to form in such a column. The freezing is just instant. And if you lower a wooden stick into a vessel with this liquid, it instantly becomes covered with crystals and then completely gets stuck in the solidified liquid. This time, the crystals seem to create a flower on a stick, but they continue to grow, filling the entire container. Let's lower a branch of a plant into the container. Having so many points of contact, crystals fill the entire vessel almost instantly. This process looks truly fascinating. I want to watch it again and again. And most importantly, every time it's an absolutely unique result. Just fascinating. We need a glass vessel in the shape of a cylinder. Look, the egg looks just like a balloon. Oh, and this refraction of light? Okay, let's be serious. Let's put this plastic plate on top, toilet paper tube, and the egg on top. Now, knock it over, and the egg falls exactly into it. Now, 3 eggs. How about 5? Easy? All 5 eggs fall right in the water. This time, we will use boiled eggs. Hard-boiled and peeled from the shell. Boil water in a kettle. Be careful with the boiling water. Pour it into a bottle. And when it heats up, pour it into a bowl. Now, let's put the egg on top of the neck and just watch the wonders of physics. The egg literally pulls in. Did you hear that? Let's look again from the close angle. Egg goes in the bottle. The same trick can be done with the burning piece of paper. The fire will burn all the oxygen inside and the egg will be drawn inside even faster. For the next experiment, I got this aquarium. How's the view? Fill the aquarium with water almost to the edge. And now, we break the raw egg inside. It immediately goes to the bottom, but it's not as simple as that. Using our fingers, we create a funnel in the water and the white egg makes it visible. Just look, it's a real egg tornado. And in the center of the storm, of course, is the yolk, which does not even think of spreading, unlike egg white, which particles have already spread throughout the aquarium. For the next experiment, we'll need an empty shell, but first, I'll show you how to make it. To begin with, you will need 2 small holes on opposite side of the egg. Now, let's take a plastic bottle and make a hole in the bottom. Fill it with water, which immediately begins to flow through the hole. But for now, we'll plug it with the finger. We fix the prepared egg on the neck of the bottom of the clay. And now you remove the finger from the bottom of the bottle and watch how the pressure will put out the entire contents of the egg, like this. Rinse the shell in water and to remove the remaining moisture, blow into one of the holes. Now, put the shell in a glass container filled with vinegar. Under its influence, calcium, which the most part of the shell consists of, dissolves. However, the inner membrane will remain intact. After 1 or 2 days, we will remove the membrane from the vinegar. Rinse it thoroughly to get rid of the precipitation. Now, dry with the hair dryer to remove all excess moisture. Inflate the membrane so that it returns to its original egg shape. And just look! Now we have a rubber egg. It is elastic and it bounces well off surfaces, just like a real ball. In this experiment, we're working with chemicals, so let's not forget about our protective equipment. Let's take an empty egg, as in the last experiment, as well as alkaline pipe cleaner, water, and aluminum. We dissolve the alkali in the water and add aluminum to start the chemical reaction. When the hydrogen vapors start coming out of the neck of the bottle, we will plug it with our empty egg so that they accumulate inside the shell. Now, we will install the shell on a stand and ignite the gas that comes out through the hole. But do not repeat such experiment at home. It's very dangerous. Meanwhile, our shell explodes! Look! Let's look at that again in slow motion. Wow! What a powerful explosion! Don't try this at home. Well, at the end, we will conduct a small crash test of an ordinary chicken egg. We will fix the egg on 2 coils of duct tape and gradually put barbells weighing 3.2 kilograms on top. Let's see how much of that it can withstand. 3 kilograms, 6 kilograms. 9 kilograms. Wow! I didn't think it could withstand so much. 12.8 kilograms. Meanwhile, the weight is as much as 16 kilograms. $19 kilograms turned out to be an unbearable burden for our egg. It turns out the maximum load that an egg can withstand is somewhere between 16 and 19 kilograms.